Hey bro, nice to see you again. Yeah, me too. This is a question for you today. If you need to reverse a single linked list, which way would you choose to solve this question? Iteration or recursion? In my opinion, I usually use iteration, but it still depends on situation at the time. Okay, why? Can you give me a reason for me? Because recursion takes up more stack space than iteration. Are you sure about that? Sorry, partly. I mean, if you use a tail recursion, it can save stack space, but not all recursion problems can rewrite to tail recursion. Moreover, many languages compilers do not support tail code optimization. For example, like Java, Python, Go, they don't support this. Okay, so what kind of problem you will use the tail recursion? Give me an example. I think Fibonacci sequence is classic problem with use recursion. Time complexity of general recursion is big O to square n. Its use tail recursion time complexity can down to the big O n. In addition, recursion is more readable than iteration, because write code recursively is like a mathematical formula. However, if the project cares more about performance, I guess recursion is useless. Okay, nice answer. Can you write an iteration method with reverse single linked list? Okay, let me write down the example. And first, for the convenience of expansion, I will write down the two null. First the null, and then node, and then 2, 3, and second null. Okay, furthermore, I need to declare 3 points where the data structure is list node. The data structure of list node is integer var, and the next point, so it's list node and next. Okay, maybe you can have a constructor like list node, and var is 0, and the next pointer is point to the null. Okay, why need 3 points? Can declaration less than 3? To me, I will say no, because it needs to point to current node and the previous node. In this way, the next pointer in the current node can point to the previous node. Here we need attention. If we don't declare one more point to point to the next node of the current node, we will lose next node address. So for my algorithm, it requires at least 3 points. Alright, continue. So first pointer I will name in prev, and I have a linked list head point, and I will need to declare next point. Okay, first thing, previous is pointed to null, and then I will scan the linked list, so it's while head. So if head in point to a null, it's break while loop. Okay, so first, next pointer need assignment head next, because if we don't do this, we will lose the next pointer address. Now we need operation pointer. So first time we head is pointed to 1, and then I need to modify the pointer to the null. So here is previous. So here is previous point, and head pointer to 1, and next point to the here. So first step, head next need to point to the previous. So previous. Okay, so this pointer will modify to the like this. Okay, sounds great. So yeah, and the second step, previous need to point to the head. Okay, so now previous. So now previous is point to the head, and then head will point to the next for the okay, so head is point to the here. The second interval while next pointer will assignment the head next, so it's do the same thing like the first step. So it will modify the pointer to the point to 1, loop to the head point to a null. Okay, so now we break the while loop, and then last step, next pointer it will point to here, and head will point to the null, and then previous will point to the next. So we just need to return the previous node, because previous node now point to the linked list head. Nice work, bro. Okay, let's move on to the next question. I will give you two linked lists named L1 and L2, and both lists are sorted in non-decreasing order. Please merge two lists and return it as a sorted list. Certainly. So I have two sorted lists, and I need to merge those lists and return a linked list in non-decreasing order. Suppose L1 is 124, and then L2 is 2238. I need output 122 and 348. Right. From the perspective of performance, is this problem suitable the recursion? Same answer with the previous question. Iteration is better than recursion with this problem. Okay, please write down the recursion method and explain why the performance is poor. Here I explain the recursion algorithm. First, the data structures of this node is the same previous question. So first, I have a recursion function. I will name the merge. And then I will input L1 and L2, 2238. And first, we will compare two linked lists. Val. So I want to extract the smaller. Here I will write down the code is if L1 val is less than L2 val, L1 next is equal to the merge function 2 This means is equal to the merge, and then L1 next and L2. So otherwise is L1 for larger than or equal to the L2 for. So here is else. In the case where L14 is equal to L24, anyone can choose to the link. It doesn't matter. So here I will choose the L2. So equal condition is same deal with the L14 larger than L24. So it's L2 next, merge to the L2 next, and then L1. Also, I get lost return L1. So here you need to write down L2. That's okay. This is my algorithm method main idea. So we can move on the example. So emerge 1. So first time 1 less than 2. So here we will extract 1. And then the second largest merge function is 24 2238. Let's move on the end of the recursion. And the 1 plus this plus like is mean point. So I need to write down the point. But this is not incorrect for the example because it will return, and then it will point to here, and the pointer to point to 1 back to the head. Yeah. Okay, so here I want to pay. We need to pay attention for this situation. Is now we need concern the end condition with recursion. If two lists are not of equal length, we still have a node to append after the main loop is started. So here is the example: L2 longest the L1. So we leave the A node in the L2, but we not link. Here we need to write the end condition. So the end condition is if L1 equal to the null or L2 equal to the null. Okay, so here is first condition. L1 is null or L2 is null. For this example, L1 will equal to a null first. So we need type return L1 L2. So this means is if L1 not equal to null, if it is yes, it's return the L1. If answer is no, it's return the L2. Okay, so this is my recursion algorithm. The time complexity is big O n, but the performance is still worse than iteration because it needs push pop variable from the stack. So I think iteration, maybe time complex is same, but iteration don't have push pop operations, so iteration have a better performance and better stack space because my recursion is not tail recursion. Okay, great job, bro. Let's move on to the next question. Could you explain deep copy for me? Sure. Deep copy refers to copy by value. That is, the copy item consumes memory space. The other is shared copy or copy by address, which means that the copy item does not consume memory space. Just use a pointer to point to the object. When we'll use deep copy or shared copy? For example, There is a buffer in the operating system called the user buffer, which is used to improve performance. User buffer should use deep copy because the user buffer is used to reduce the number of the system code, and it's for the user to rewrite object and then write the update data back to the kernel buffer at a time. So this is the reason why I should use deep copy. Okay, nice answer, Blue. This is not structure used in a question. So node have interval. Okay, so it's class node and then interval. And then you will have a point. Structure is node and in next. This is mean this pointer will point to the next node, and the other pointer is random. And the random pointer will random link to the node of linked list. Please deep copy the linked list created by this structure, and what is problem you will face on. Okay, how to solve those problems? Can I use an array to store new node address? What idea? Keep eyes on your email. We will tell you next meeting time.